Hi, this video goes over construction and operation of a waste oil furnace that I built to heat my shop. Now, the furnace itself is a commercially available Olson downdraft oil burning furnace. I bought it used off of Craigslist. I kept the majority of the furnace parts, the body and the combustion chamber and the blower, and I've converted the Beckett burner that was inside of it to run on waste oil. I built this about 4 years ago and burned close to 4,000 gallons of waste motor oil, hydraulic fluid, and vegetable oil through it. I really haven't had any major problems with it. A couple of filter changes and a couple of heater changes, which I would consider to be routine maintenance items. Aside from those few things, it's performed flawlessly for me, and it does a really good job of keeping my shop up to whatever temperature I want to keep it at. Okay, what we're going to do is take the cover off the furnace, and I'll give you a quick tour of the internal components actually inside of the furnace. Okay, this is a standard Olson 80,000 BTU downdraft oil furnace. What I've done is just taken out the burner itself. I've left the combustion chamber and the fan and the transformer, all the electronics intact, and I've just modified the burner itself to run on waste oil. So what we have is a Beckett AF series burner right here, and really all I've done is change the nozzle block out in it. I have my air pressure regulator right here. Right now it's set to about 17 psi. I have my air pressure solenoid, which is actually what turns the air on and starts the air and oil flow through the nozzle. I have the factory Olson transformer and relay right here. This is the relay that operates and applies power to my temperature controllers when the thermostat calls for heat. I have the two temperature controllers right here. The top one is to control the temperature inside the nozzle on the burner, and the bottom one is to control temperature inside of my siphon tank, which holds my oil at a constant level just below the center line of the burner nozzle. And then up here I have a couple of relays. The two relays on the bottom are controlled by the two temperature controllers because the heaters are a relatively large load, and the temperature controllers, internal relays, can't handle that much current. So the two temperature controllers control these two relays. One is to run the immersion heater inside my siphon tank, and the other one is to run the cartridge heater inside the nozzle block. And then my time delay relay is the relay that controls my oil pump that actually pumps oil up into this siphon tank. And the reason I have a time delay relay on there is so that if my filter gets clogged, that the pump doesn't run all night and burn itself up. It actually only allows the pump to run for about 60 seconds. So I know that if that relay is timed out, then it's time to go out and change my oil filter. Okay, this is my siphon tank right here. And what's inside of this, you can see there's three openings right here. Now this is actually the oil outlet. This is where the nozzle actually draws the oil out of the tank into the heater. The pickup for this is about down in the center of the tank, so it's drawing nice warm oil. And if I do get any water or anything inside of it, it's not drawing it off the bottom where the water would tend to collect. Now this right here is a brass air filter. That way as the oil goes into and out of the tank, it's actually at atmospheric pressure, so we don't build pressure or draw a vacuum inside of here. Now that's really important because since this is a siphon tank, since this is a siphon setup, this tank has to be at atmospheric pressure. If it was sealed, there's no way that the siphon would actually work. And then right here what we have is a float switch. And that float switch has a very narrow dead band. It's about 1/4 of an inch. So the oil level actually sits right about here in the tank. And as it goes down about 1/4 of an inch, then that float switch will kick on our external oil pump, and it'll raise the level by about 1/4 of an inch. Now this level is important because the level of oil below the center line of our burner affects the firing rate. The lower the oil level is, the less firing rate that the burner actually has. Now this component right here is a water trap, and what it does is it just separates out the water before it reaches my siphon tank. And I found that almost every barrel of oil I put into my oil tank out there, I do get a little bit of water in, probably from condensation. And it does a really good job of separating out the water, but because of the heating and cooling that goes on in this tank, I also get some condensation in this. So Periodically, once every couple of weeks, depending on furnace operation, I do have to drain both tanks. And I'll get generally just a few drops of water out of them, unless I've added a fresh barrel of oil, and then I might get a cup or two out of my actual water trap. All right, now what I'm going to do is go ahead and turn up the temperature on the thermostat so that it calls for heat. And what you're going to see is these two temperature controllers turn on. The top one is the controller for the heater in the nozzle block, and the bottom one is the controller for the heater in the siphon tank. Now the set point for the siphon tank is 80 degrees, and the set point for the nozzle is 180. And those are the target temperatures. The point where they actually enable power to the burner for the nozzle block is 164 degrees, and for the siphon tank is 70 degrees. So as long as we're above 70 degrees in the siphon tank and 164 degrees in the nozzle, then it'll actually turn the burner on. Now the furnace has been running tonight. It's fairly cold out, so the temperature should already be fairly high. If it doesn't turn on right away, it should turn on within just a few seconds. You can see the nozzle temperature is a little bit below its set point. It's going to start rising fairly rapid here. As soon as it gets to about, once you see 165 degrees, you should be able to hear the burner light off. Okay, right now the burner is running, and it's going to run for about a minute or so without the air circulation fan going, just to allow the temperature to rise to a point where it's actually producing some heat. Okay, I've gone ahead and turned on the thermostat. The furnace should kick on here any moment. Okay, you can hear the combustion's actually started in here. We have our little viewing window right here, so you can actually see the flame down inside the combustion chamber. When it first ignites, there is just a little bit of smoke, just for a few seconds, and the flame starts out fairly small. Once it goes a good draft going up the chimney, then the smoke is completely eliminated, and the flame gets quite a bit bigger. The furnace is just ignited, and it's not actually producing any heat yet. The fan's still off. As you can see right now, our thermometer shows about 60 degrees in the air plenum. After a minute or so, the furnace's fan will kick on, and it'll start to circulate heat throughout the shop. Okay, the furnace's blower is kicked on. You can see right now the temperature's starting to rise. We're about 80 degrees right now. That sound is the sound of the oil pump pumping oil from my holding tank outdoors into the siphon tank. Right, the furnace has been running for several minutes now. As you can can see the temperature coming out of the outlet plenum is now about 110 degrees. We get about 112 there. It's actually producing some pretty good heat. It'll get all the way up to about 130 degrees if the furnace runs for 5 or 10 minutes. That's about as hot as it gets. If it gets much above that, then it kicks the burner off and allows the blower to run for a few minutes